Hello, so we're going to finish 1.6. This is the second video from 1.6. Before we continue on with our discussion, I want to point out I did make a mistake in the last video, and I have the problem here. If we look back, the original problem, I will highlight it in red, is this was the original thing, and when I added it to both sides, notice I switched the sign. Which if you switch the sign back, so change that to a negative, 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 this becomes negative, that's negative, or that's negative, that's negative. You will notice that this becomes -4, which makes it a 1. 1 squared is 1. This negative, negative. So you add 3 and you get x equals 4. And x equals 4, if we try it in the original solution, it will pan out. You'll have 9 minus, so square root of 9 minus square root of 1, so 3 minus 1 does equal 2. So just letting you guys know, even I can make a mistake with the sign every once in a while. But the logic for the problem was valid. I just did a sign wrong and got a wrong answer. But you can get no solution, so at least you understand that concept. So now let's continue on with our discussion. So the fourth type of problem they're going to have us solve is a rational equation. What's a rational equation? We have to understand what a rational expression is. This is a rational expression. It's just another way of writing the nth root to the mth power. So it's a way of writing that. So this is the nth root here. This is the nth root, and then this is your m power, raising it to the m power. The other thing to notice about rational equations is that a to the m to the n equals some k, right? We have this problem, a to the mth over n, should be n, I keep on making a mistake. We want to get rid of this power here, this fractional power. You do it by raising both sides to the reciprocal of the power, which is n over m. Okay, and that'll get rid of these. But you have a condition. You have to know whether m is even or odd. So you have two cases. If m is even or if m is odd. So if m is even, then this equation can be solved by, again, raising both sides to the reciprocal of the power. It's just you're going to have plus or minus. And you'll have a equals plus or minus k to the nm. That's if m is even. If m is odd, however, when you raise both sides to this reciprocal power, you will not have a plus or minus. You just have that. And the reason is because of how, when you square something, if you square a negative number and square the same number but opposite sign, you get the same answer. So with even powers, with even m's, when they negatives become positive, positive remains positive. So you always end up with two sets of possible answers if there is a solution. Okay, so these are rational expressions. I'm going to work out some here to solve. So simple examples. Example 1, you have 5x to 3 halves minus 25 equals 0. What we're going to do here is we're going to move the constant over to the right hand side, then divide by the coefficient in front of the x term. Okay, so we'll do that first. then divide both sides by 5. Okay, now we multiply by or raise the reciprocal power on both sides, which would be 2/3. That's the reciprocal of 3/2. Okay. They cancel. We don't have plus or minus because your m is odd. 3 here, this is an odd number. And if you look up here, if m is odd, m is here, then you don't have your plus or minus. And you get your final solution, which is x equals 5 to the 2/3 power. Okay, which is really the cube root of 25. That's what that is. Okay, so there's one example. Let's look at another example here. Okay. Now we're going to add 8 to both sides. You have x to the 2/3 equals 4. Now we're going to raise both sides to reciprocal of 3/2. But here, because your power is even, that means we're going to have plus or minus. So we're going to do plus or minus here. So x equals plus or minus 4 to the 3/2, which another way of writing is that plus or minus 8 is actually what that is. If you square root 4, right, we could rewrite this as square root of 4 to the 3rd power. So square root of plus or minus. Square root of 4 is 2, 2 to the 3rd is 8. So this will give you an answer of x equals plus or minus 8. Okay, one other thing to note when you're doing these, like on this same problem, I'm going to do a similar problem. So let's say we have x to the 2/3 equals -4. Now, when you raise both sides to the 3/2 power, here, let's just write this over. Remember here that if the denominator number is even and there's a negative on the inside, then these are imaginary numbers, because this is another way of rewriting this. And don't forget our plus or minus the -4th here, and then that raised to the 3rd. Well, what's -4th square root? Well, that's going to be plus or minus 2i to the 3rd power, which is going to be plus or minus 8i cubed, which is going to be minus or plus 8i. Okay, so you do have to be aware of if these are evens, you will end up, if you have a negative inside, with an imaginary solution. So those are dealing with rational expressions. Now let's move on to the next type of equation we're going to be solving, and that's 5 is U substitutions. So U substitutions these are all quadratic-esque or quadratic-like. So these are things that almost look quadratic. They almost look like ax squared plus bx plus c. They just have an issue or something. If we didn't have that issue, we could easily factor it. So I'm going to do a simple example here. Most simple one is x to the 4th minus 10x squared plus 9 equals 0. Now, if this was here, the problem is this is a 4 and this is a 2. If this 4 was a 2 and this was a 1, we'd easily have it. I mean, we know what x squared minus 10x plus 9 is. That factors into x minus 9, x minus 1 equals 0, and then we'd have x equals 9 and x equals 1, right? So we know that, but it's not a square, and there isn't a 1 here. So what do? Well, what we do is called U substitution. We substitute U equal to x squared. If we do that and we plug it into here, into the original one, you're going to end up with U squared minus 10U plus 9 equals 0, because x to the 4th is this squared, right? So that's u squared. So it's u squared minus 10u plus 9. Then you could, solve this. We already know what this is. This is going to be u equals 9 and u equals 1, all right? But what's u? U is x squared. So now you substitute back in what u is equal to. Then you have to solve for x by taking the square root of both sides. Don't forget your plus or minus. So take square root of both sides, plus or minus, square root of both sides, plus or minus. You get plus or minus 3, and x equals plus or minus 1. And you end up with 4 answers. X equals -3, -1, +1, and +3. Okay, so that's called u substitution, and we do it when an equation almost looks like it's quadratic. Okay, so there's an example of u substitution. I'll do another example of u substitution. Let's say you have another example would be this, x minus 5 squared minus 4x minus 5 minus 21 equals 0. This is almost, if we could think of this as u, this could be u squared minus 4u minus 21 equals 0. Well, what's u in this case? Well, u in this case would be u equals x minus 5. If we substitute x minus 5 with u, we'll have u squared minus 4u minus 21 equals 0. And we know what 21, the factors of 21 are 21 and 1 and 3 and 7. And we're doing subtraction because of this guy here. So we're subtracting to -4. So we know that 7 minus 3, -7 plus 3 is -4. So we can factor this down into u minus 7, u plus 3 equals 0. Then we have our two solutions, so u minus 7 equals 0, u plus 3 equals 0. This is u equals 7, so u equals -3. But u, we're trying to solve for x, not u. So now we have to substitute back in what u equals, and u equals x minus 5. So u is x minus 5 equals 7, x minus 5 equals -3. Now we solve these by adding 5 to both sides. And we end up with two solutions, x equals 12 and 2. So there's another example of a u substitution. Okay. The last example, so I'm going through basically 3 categories here of u substitution. The last example is if we kind of have almost a radical, it's a radical like type problem here. Okay, so we have this problem here, and we know that if we look at these, this is almost, again, this is almost 5x squared plus 11x plus 2 equals 0, which we know 5 times 2 is 10. 2 factors of 10 that add to 11, well, that's 10 and 1, so we know that we can do, by grouping, we can redo this and solve it if it was like this. But it's not. The problem is these are not 2, it's a third. But we notice that this guy here is 2 times 1/3, and this is a third. So that should tell us that if we do this u substitution with x, if u equals x to the 1/3, we substitute that, then we will end up with 5u squared plus 11u plus 2, which we know we can solve. Okay? So that's the u substitution we're going to do. Then we're going to multiply 5 times 2 is 10. Factors of 10 that add to 11 are 1 and 11. You're going to have to do factor by grouping on this guy. So it's going to be 10u plus 1u plus 2 equals 0. Put in your things. Here we're going to factor out a 5u. Here you can't factor anything, so you need to at least factor 1. Now the two things are identical here. So factor by grouping says we can regroup them. Okay, and then we can separate them into 2 parts. So this is u plus 2 equals 0, 5u plus 1 equals 0. Here it's u equals 2. Here, subtract 1, you're going to end up with u equals negative 1/5. Subtract 1 and divide by 5. Now is when we do our substitution. U really equals x to the 1/3. So this is x to the 1/3 equals 2. This is x to the 1/3 equals negative 1/5. Now we need to get rid of, now we treat it as if it's the problems from earlier. We need to raise the power of 3 over 1. So now is when we put in 3 over 1. Here's 3 over 1. So this would be cancel. So this is x to the 2 to the 3rd, which is 8. Here, if we were 3 over 1, 3 over 1, we get x equals negative 1 over 125. And that'll be our two solutions. So we've got 3 examples that we looked at here with u substitution. First one was the simplest one, where if we look, I'll go back over it. If you look here, notice that this is just 2 squared and this is 2. So you're going to be looking for these patterns where it's 2, where it's some number and then the number squared. So 4 and 2 are a pattern. It could have easily also been 9 and 3. So it could be x to the 9th. And then you would do u equals x cubed, which means u squared. Or wait, not 9, 6. U squared would be x to the 6th, right? So you're looking for when it's this number, or I guess this number here equals this number times 2, right? So 4 equals 2 times 2. 6 equals 3 times 2. The next one up would be 8. So it could be x to the 8th equals x to the 4th. So then you do a u substitution x to the 4th. And these are very similar to the last ones that we did. We noticed that on the last one, this guy here was 2 times the 1/3 here. So that's the pattern that you should look for when doing those. And then on this one, they just pretty much give it to you here, where it's just you have a square and you have something inside, then it repeats. Okay, so there's your u substitutions. And the last thing in this section is absolute values. We already solved absolute inequalities, so really this section is not anything different. So you're looking at 2 cases when you have a equals some k, absolute value of a, and then you have 2 possibilities: k is greater than 0, k is less than 0 with absolute value. So if k is greater than 0, if you're the first case, case 1, then what it is you rewrite it as a equals plus or minus k, and you solve for whatever a is. If you're the second case, then there's no solution. Because that would be like, let's say you have absolute value of x equals negative 2. Well, no value that you place into x is going to return negative 2. Because you put a negative number, absolute value, and make it positive. So those are your 2 cases. So let's look at an example here. Example 1, I'm just going to do one of these since we already covered this earlier. Let's say we have this, okay? And, well, first of all, we notice here this number is greater than 0, so we're good. If that number had been less than 0, then we couldn't go any further. It's greater than 0, so then what you do is you rewrite it as 2x minus 3 equals plus or minus 11. And then at this point, you're just following out, add 3 to both sides. Or I guess you could break it up in 2 parts here. Let's just do that first, break it up. So you're going to do 2x minus 3 equals positive 11, and 2x minus 3 equals negative 11, and then do it in 2 parts. Add 3 to both sides. You get 2x equals 14, divide by 2. You get x equals 7. Over here, you add 3 to both sides. You get 2x equals negative 8. Then divide both sides by 2, and you get x equals negative 4. And you'll notice both of them will work. Plug 7 in here. 7 times 2 is 14. 14 minus 3 is 11. Absolute value of 11 is still positive 11. And then you plug negative 4 in. You get 2 times negative 4 is negative 8. Negative 8 minus 3 is negative 11. Absolute value of negative 11 is positive 11. And so they both work. And in these, you need to always check. Okay, so there's an example of an absolute value. As far as problems here, I want you to think about, so we cover these different problems, and I want you to think through carefully the 6 different examples we did here. I gave some in your homework for each of them, and try to work it out. If you have questions,